Okay, I believe I'm now recording not quite 6 o'clock yet. I'll give it about another 3 minutes.
Oh, Dr. Kings.
Recording. Today is 1/25/2018. It is 6 o'clock, and this is Collin College, the regularly scheduled meeting of ITSE 2309. Professor Stephen Smith speaking. So this is the regular class on Thursday evening, 1/25. A couple of little announcements or housekeeping. First of all, Dr. Sharma is not the professor of this class. Lots of people are emailing him and he's saying, why are all your students emailing me? And don't email him, okay? In general, don't use my email unless it's urgent. I'm meaning that you need to talk to me about something that doesn't have anything. If it's a routine class matter, what time is our next class meeting? When are we having the test? Use Canvas email. If it's just something, if it's like, when is something due? Okay, told you about my due dates. My due dates are soft. Now, that said, I do have one important one that's coming up. I have to certify the class roster. And that means that on the class roster, I have to have something turned in. You can mute that. No, I guess you can't. I guess you'll have to hear it. I have to have something turned in. So I can say, okay, you've been here, you've done something. So at least turn in the syllabus quiz. That should be simple enough. And even if you don't get them all right, turn it in anyway, or just do it, and that'll record a grade. And then I can say, yes, I have something that says you've been here. Okay. Otherwise, I have to report you as non-attending if I just don't have anything. So we don't want that to happen. Okay. Issues on installation at home. People, if you have issues on installation, you can email me and I'll be happy to try to help you. I can't really fix your computer at home, but I can try to guide you through the process. So, let's see. One other issue that has come up 2 or 3 times actually is if you have Windows 7, you will have to install Microsoft Server version 2012. Okay. Now you can install version 2014, but 2012 is a more stable. It was a lot. 2014 didn't last very long, and then they upgraded quickly to 2016, so it never got fully tested. I would use 2012. You'll see everything will be just about the same as it is. In fact, you could use the 2012 textbook. But so if you have Windows 7, you'll need to download Office 2012. And let's see, here we go. I'm a great believer in Notepad++. I really like Notepad++. You don't have to use it. It's a very nice little text editor. And what we're going to be talking about today is Module 3, and we are going to be creating tables. And I have up here an example of a create table statement. Create table statement, essentially SQL breaks into 2 different features, and one of them is the part of it that creates tables and creates the data, and that's called the data definition language. And then there's the queries. Now, our textbook starts off with queries, data manipulation. But I have jumped ahead in the textbook about, I give you the page numbers for reading in Module 3. So we're up ahead, we're up in Chapter 7 right now, which is a little far ahead, but actually we need to get this part out of the way because I need to talk about a database and talk about tables and how tables come into existence. Okay, let's talk about database in general. What is a database? What is a database? Holds data, yeah, okay. It's tables, it's organized data. It has some properties. First of all, a database is huge. A database is too big to fit on a floppy disk, too big to fit on your flash drive. Now, that said, of course, you could put a table on your flash drive, but you wouldn't be happy with it. So it's really big. The other thing is it organizes data. There are 3 basic rules that go with database. And these rules are called the first normal form, and they're in the module. 3 things that it has to be. The first one is there are no duplicate rows in a database. Each row, each table, each record in a database is unique. So a database would be, is there anyone who hasn't used a database? Okay, have you used Access? Have you used a telephone book? Don't say yeah, like it's obvious. Today, kids are coming in and they haven't used a telephone book. Well, okay, in a telephone book or a directory of some type, you have a name, you have a telephone number, you have an address with it, and it all stays together. Okay, but there are no completely duplicate records. So think of a database as a card file, and in this card file you have a card, and on that card is some information. There cannot be 2 cards in that file with exactly the same information, and it has to be different in some field. Okay, well, no duplicates. We can come back to that in just a second. Okay. The other thing about a database, the data are accessed only by the content of the record, meaning I will never ask for the 2nd record or the 3rd record or give me the last record in the database. Now, you're going to see this gets violated a little bit, and some of these rules do get broken. But in general, I'm going to say, show me all of the records where the address is in Frisco, Texas. Show me all of the records with last name Jones. Show me all of the records who live on Oak Street. Okay, and it comes back with all of those. Database is very good at that. You'll never ask for show me the first 10 records, although we're going to see that sometimes they do that. Okay, so so no duplicate records, accessed by content only. The other thing about a database is semantic. A field has exactly 1 value. What do I mean by that? A field has 1 value. Of course it has 1 value. How would it have many? Well, if you're familiar with Access, it lets you have many values. But a field, for example, up here on the board, or e-name, there is an employee's name in that record. Okay, I'm going to talk more about it, but that record is named e-name. Well, is a person's name, is that 1 value? Do you just have 1 name? I guess Sting has 1 name. There's a performer named Sting. He has 1 name. Cher had 1 name. But most people have a family name and a surname is the family name. So their personal name and then the family name is with it. Okay. Well, if I have the full name in there, Joe space Blow, that's violating that, unless I always treat it as 1 piece. And we're going to see that I can go in and pull out the last name. If I've got first name, last name in a field, I can go in there and get that last name. But I'm supposed to say that when I have the value in that field, it is exactly 1 value. Okay, questions on that? If I'm pulling it apart, it needs to be 2 fields. Okay, so let's go back to number 1. And number 1 was, and that, by the way, that is called the first normal form. So if it conforms to that, I'm going to let you call it a database. Let's go back to number 1. Number 1 said no duplicate records. If there are no duplicate records, can some of the fields be duplicated? Why, of course they can. I can have more than 1 person that lives in Frisco, Texas. Therefore, is there some field? What is the smallest thing I can have? 1 field preferably, or preferably 1, but could be more than 1 field. Is there 1 field that uniquely identifies 1 record? Is there 1 field that I can pick out that by design will be unique There it is, SSN. Okay, and I wrote that up there. I call it SSN because I wanted to to show up as that's the Social Security number. Now this is what we call the primary key. Okay. Now every table must have, in order for you to call it a database, every table must have a primary key defined on it. It will let you have a table that you don't, but it's bad. Just because a database will let you do it doesn't mean it's good to do. So all tables will have a primary key defined, and down there at the bottom of the page up here you can see where I define the primary key. Right there, primary key. A primary key is something, it's that field which is guaranteed to be unique. The other thing is that every record has to have one. It cannot be empty. You can be in this database and not have a date of birth. I don't know your date of birth, I can just leave it empty. If I don't know your salary, I can leave it empty. But I cannot leave the SSN empty. You have to have an SSN to be in this database. And it must be unique. You with me? We're going to come back to that. It's going to be important to our life. The primary key is that piece of the table that orders it and by which you would like to access it every chance you get. Questions? Okay. So with that in mind, question.
And you only have one, you can't have two.
You can have a question was you only have one primary key. That is true. You can only have one primary key. However, a primary key can be more than one field. It is not preferable. It is preferable to have one field as the primary key. Social Security number is the best, but I don't always have access to that. For example, at Collin College, I'm not allowed to know your Social Security number, or I'm not supposed to ask for it because it's a primary key. That's kind of why. But if I'm an employer or something, I have your primary key. Okay, let's take a look at this create table statement. Again, this comes, I believe, from chapter 7, and I'm not going to deal with row 1 and 2 right now. Start right here, create table employee. Let me tell you a little bit about SQL language. So this is the SQL language that we're looking at. It's our first example of SQL. SQL does not care about uppercase, lowercase. SQL is not case sensitive. That said, we type it as if it's case sensitive because when I'm typing one of the reserved words of SQL, I will type that in all uppercase. So when you type CHAR, I'm telling you that, and by putting that in uppercase, I'm recognizing that as a reserved word. I can type SQL in Notepad just fine. I don't have to have a text editor for it, a special programming editor. Notepad's fine. I can type it in Microsoft Word if I want to. So, char. Now, create table are reserved words. I type them in uppercase. Employee. SQL language does not care where you break lines, but I do. Okay, your reader does. And if you just have it kind of thrown in there willy-nilly, it's very difficult to read. So notice how I have done it. I say create table employee, and then I press enter. I have the parentheses, open parentheses, on a line by itself, line 5. And I will give you a copy of this file. So the file is going to be put out onto in our files. I'll send this out. And okay, then I tab once. I give it the name. Tab enough times to make it line up. I give it its type. When I say it's char, I'm telling you that this field occupies exactly 9 characters. If you don't give it 9 characters, it pads it out with spaces. This field always occupies 9 characters. One of these days, we're going to run out of SS, Social Security numbers. You laugh. It's going to be a big deal when we do. We only have about 4 billion or so. 9 digits, 1 followed by 8 zeros. That's a billion. Once we hit a billion Social Security numbers, we're running out. We're running out very quickly. Probably in the next few years, next 2 or 3 years, I expect. You'll start hearing about it. I expect that what we will do is, instead of numbers, we'll go to letters. That'll buy us quite a bit of time right there. But sooner or later, we're going to have to get bigger. So I usually will add a couple of characters to it, because making something too small in a database is a disaster. You ever heard of the Y2K problem? It's too small. Okay. It was a database problem. Okay. So we really want to give it enough room. I might give mine 16. I don't know. The problem with making it bigger is I'm adding size to it for every record. I'm adding the size. Okay. Then there is a comma. Comma. Then I skip to another line. If you didn't, it would still work, but I would get angry. You don't want me mad at you, right? Name. Now, notice what I have done here. Notice, let me stop and talk about the names of fields. My fields all begin with the same letter as the table. My tables is the table employee. All of my fields begin with E. The table name has to be unique. The field names within the table have to be unique, but they can be the same as in another table. I like my field names to be unique, period. Therefore, I will add enough of the table name to make it a unique name. So, for example, if the table name begins with E, I'll add E underscore. So all I have to do is see the name of the field, and I know exactly where it comes from.
Mama, safe. And I've got a place to lock it. What the? Huh?
Okay. Let's see. I am not. Okay, I'm still on. So I have E underscore. The other thing is, Microsoft products will allow you to put spaces in the field names and in the table names, for that matter. Do not do it. Do not ever do it. Excuse me. Okay, putting a space in a field name is terrible. We don't ever want to do that. So we have the I use the underscore. Now, if you have a space in the name, and somebody, or you pick up a table that somebody else has built and they have put spaces in it, in order to use it, every time I do it, I will have to enclose it in square brackets. Some people always put their field names in square brackets. Some don't. I'm not a user of them because I never have spaces in my field names. So I don't feel that I need the square brackets. But you will find that if you generate it by a computer program, it will automatically put brackets on it. That's there to allow you to have spaces in your field names. Just don't do it, and you don't have to worry about it. So this one, e-name, is a varchar. What do you think varchar means? Variable length characters up to 32 characters. I don't know really what else to say about it. Which the char always takes up 9 characters. Doesn't matter. Always takes 9. That's an array of characters. Varchar is essentially a string that can grow and shrink. The fixed length is a better choice if it's small. If it's only 9 characters, it's not worth paying the cost because that it grows and it shrinks at a cost. Nothing is free. EDOB is a date. We have a data type for date in database. Date is, actually it's an integer, and it is the number of clock ticks that have elapsed since time 0. Anybody know when time 0 was? 1970. Yes, it was the new year of, the stroke of new year of January 1st, 1970. I don't know why they chose that, but if it's negative, it's before that time. Okay. E-salary is, I've made this one be money, and in SQL Server, it is spelled M-O-N-E-Y. Other servers, other database platforms will call it currency. Currency. And SQL Server calls it money. A little bit of difference there. SQL is supposed to be exactly the same in all applications. It is not necessarily. Okay. There will be some differences. I'm going to point those out to you. Money and currency is one of them. If money doesn't work, try currency. Money. I'm going to come back to money in just a minute. This is just a number. I don't know what number, I don't know what E number means, but this is an example of a numeric data type. It is a number. Now, this number is big enough to take 9 digits. You see the first number, the first parameter there is 9. It's big enough to hold 9 digits. Are to the right of the decimal place. Is that clear? It's not, you don't add them together. It's the first one tells you how many digits, and then the second one is subtracted from it and put to the right of the decimal place. Those two to the right. Okay, questions? Now, I'm going to skip over this one for just a minute. This is shoe size. I guess shoe size is an integer, int. Also, you'll see it written INT or INTEGER. Either way, it tends to be both. I believe SQL Server will let you abbreviate it as INT. I personally prefer to type it out. SQL tends to get a little verbose sometimes. An integer, what is an integer? Okay, a whole number. 1, 2, 3. What about negative numbers? Yes. Zero is an integer. There's no theoretical upper bound to an integer, but there is always an upper bound in computing. There is no such thing as infinity in a computer. They don't go to infinity. We're gonna have a whole chapter dealing with that. Okay, but we like integers. We love integers. Here's what we hate. EIQ, floating point. I don't know where the decimal point is. A floating point is a number like pi, square root of 2. I might have, I don't know where, it's got a decimal point out there someplace. I don't know where it is. Maybe it's got 1, maybe it's got a bunch of zeros, maybe it's got 1, maybe it's got 50. I don't know. And that is very, very difficult to deal with in a computer. We want to avoid using floating point every chance we get. Now, with that in mind, okay, I like integers and I hate float. What about this? Numeric with 2 decimal places. Okay, now let's think about that a minute. It's always got 2 decimal places. In fact, that could be money for that matter. You do money like that. Okay. 4 decimal places? Yes, money has 4 decimal places. That's right. In that particular, on line 11, it says that that field is big enough to hold 9 digits 2 of those digits will be to the right of the decimal point, always. Sure. Yeah, you'd have to recreate the table or alter the table, but it's not going to change. It's not a good idea to change it. But yes, it can be changed. But you can, if you wanted to, on your table, you had a different idea, and you wanted to do 7 and 3, that's fine. Money, by the way, has 4 decimal places. Now, tell me about it. If it's always got 2 decimal places, always that field always has 2 decimal places. E number, 2 decimal places, always. Do I have to store it as a floating point? Is that really a floating point? I know where the decimal is. Okay, I'm not going to record your salary as, or your pay rate, whatever, as $15.32, 15.32. No, I'm going to record it as 1,532 cents per hour. I'm going to shift that decimal point out. It's an integer. I don't care how many decimal points it's got. If I know where it is, it turns into an integer. I just shift it out. When I show it to you, I divide it back in. Okay, so anytime I have numeric and I have fixed decimal point place, I know where it is. So I don't mind those. I get float is something I don't like. Also, you will see it used as real. By the way, this is a comment. Real is a, it's a, sometimes you'll, this one is depreciated. You should use float instead of real, but you'll see it in older programs. You'll see it will use the word real instead of float. Couple of things. Did you see my comments there? The dash dash introduces a comment that opens the comment wherever it is. It goes to the end of the line. It comments out the rest of the line. Also that I can do the C style comments. This is a multi-line comment. It's as many lines as I want it to be. Okay. I use the dash dash when I'm programming, and I use this to disable a whole piece of my program because it can span those dash dash comments. It is good practice in a statement. This is a statement. From the opening of the statement to the semicolon at the end is a statement. It is a good practice not to have any blank lines inside of an SQL statement. SQL Server will not have a problem with it. Other platforms, i.e. Oracle, will. Okay. So get in the habit of not putting spaces in there. If you want to put a space anyway, put a dash dash on that line. It's a good habit. It is good practice. Now, if I didn't have that, SQL Server would just run right past the blank line, wouldn't have any trouble. Oracle would terminate the program right there and kick me out. Okay. So we've gotten this far. Questions? Okay, I'm finished here. Notice in between each one of them, I have a comma. I don't have any completely blank lines. And now we get down to line 17. Line 17 is what we call a constraint. A constraint is something that is added to the program. Now you're going to see another way to do this. I'm going to go ahead and mention it. This is the way I want a constraint written. The constraint is named. What is the name of that constraint? It comes right after the word constraint. Employee PK. PK means primary key. So when you see the name of that constraint, you know exactly where it is and what happened. It is possible both of these won't work, but you will see it done like this. Okay. This is a legal in SQL is legal. If I put it like that, that's called an inline constraint. Or an anonymous constraint, does not have a name. If I violate that constraint, I get a very cryptic error message. Instead of that, you can't do both of these, by the way. I'm going to name the constraint. If I ever violate that constraint, I will see the name of the constraint in the error message. So I'll be able to go back to the table. That, by the way, I'm going to keep this program, and I'll be able to go back and read. I know what table it came from. Go find the table in my documentation. Got right. Oh, I violated the primary key. I should have known that by the name. That means that it's either null or I have a duplicate. Primary key, ESSN. If I have two fields in the primary key, I put them here separated by a comma. Typically, we won't. And then a blank line there, constraint. This is the employee null name. I'm going to check that ename is not null. I cannot say equals null. I cannot say not equals null. I cannot say greater than null. I cannot say less than null. Is my car older than, newer than, the same age as your car if I don't have a car? It doesn't make any sense. I think what happens is they all come back false. I don't remember exactly. I'd have to test it. But we'll never say ename does not equal. We have to use the word is not. So is a way we compare for null. We have a saying in database, nothing gives us lots of trouble. And it does. Nothing gives us lots of trouble. Null is nothing. And that's a real problem for us. But check that you have a name. Now, there is another little issue with that name. What if I had a name, but my name didn't have any letters in it? Can I have a name with no letters in it? You shake your head, no. People are shaking their heads saying, no, no, no. Mm-hmm.
It's just asking for a character. It doesn't matter what it is.
It can be no characters at all, right? The null string, the string with no characters in it, quote, quote, is a valid string. It is not null. It's called the null string, but it's not null. It's not nothing. It's something. It's a name. It just doesn't have any letters in it. That's a problem. How many of you have had the access class? Okay. Do you remember one of the things that you set up in there was allow zero length? So one of them on each field, it says, is it required? You check yes or no. The one right after that said allow zero length, yes, no. So you could have it, but it have no letters in it. That's what that was about. We're gonna fix that problem later. Okay, right now I've got the table. Okay, questions? Now, if I go to my SQL server, I like using this guy because I can just file, I can save him, and over in my server it will ask me if I want to load him again, but I can just open him.
Did you want to leave that top part commented out?
I will for now. Mm-hmm. So now he's open. And many times I will edit. Now I can edit it here too. I can edit it here. I can increase my size and all that jazz. So I can edit it either place, and you'll see me do both. Okay, this top part's commented out. I'm going to talk about that. Now, if I want to test my file, I'm going to go execute. Now, I'm going to get an error. And the reason I'm going to get an error, it says there is already an object named employee. I've already run this once to test it to make sure it worked. So to fix that, is where this top part comes in. If object ID, notice that employee is in a single quote. Everything in SQL is single quote. There are no double quotes in SQL. If you see me write a double quote, say, Dr. Smith, you're writing C again, or Java maybe. Single quote in SQL, single quote. Now, if object ID employee is not null, drop table employee. In other words, look out there, see if you have one. This line right here. Let me turn on my line numbers. Let's see if I can remember how to do that. Tools, options, text editor. All languages, general, line numbers. Okay, I'll go through that again for you. It's nice to have line numbers to talk about it. Line 2 and 3 is not SQL, but SQL always has what we call a wrapper language around it. And SQL proper is an ancient language. It's not very useful for most things, except for accessing a database. Therefore, they give us another language wrapped around it. And this is, I've stepped out of SQL up into that upper language. Anytime I'm talking about if, then, else, or while loops or anything like that, variables, things like that, I've stepped out of SQL. So this is just a handy thing to have. Notice this little line, if object ID, you put the name of your table, whatever it is right there, is not null, drop table employee. Now, if I execute this, it will execute successfully. And that's a good thing to do right at the beginning of your, if you just say drop table employee, then that will have an error if there is no table. So check and see if it exists. If it does exist, drop it. If it doesn't. Okay, other SQL implementations will have something called create or replace table. Let's see what time. Okay, 6:30, 6:40 or so. We'll have to take a break in a minute. And then it creates the table. Questions? Okay, I'm going to go back over to this guy. I'm back in my notepad because I like programming in Notepad. You will see that in SQL Server, you will see the word go. Go is unique to SQL Server. It is not necessary here. It is not wrong. It is not right. But you will see it used many times between table creation and stuff like that. Go breaks it up into two different programs. Go says, finish that last program. Now start a new program. Okay. Sometimes later in the class, we're going to need to have it for some things. I'm just going to tell you what it is in case you see it. Some students will put go between everything. You may, you don't have to. But it's not wrong usually. I can't think of any place that you're not allowed to have it. You can't have it in the middle of a statement, of course, but between statements, if you put it there, oh well. The space line, the lines. This is outside, this line 24 is outside of a statement. So this really doesn't matter right here. I don't care whether there's a comment there or not. You don't have to worry about it. So once we close it, I guess I'll talk about the semicolon. SQL Server lets you get away with no semicolons. SQL proper demands semicolons. I am going to demand semicolons at the end of every statement. Just because SQL language, which is what we're in, does require semicolons, even though SQL Server lets you get away without them. Okay, I'm not going to let you take the shortcuts that are in SQL Server, because this class about SQL. It's going to be pure SQL. I'm not going to belabor lots of stuff. There's stuff in the textbook that is unique to SQL Server. I'm going to depreciate that stuff or de-emphasize that stuff. I might mention it. Go, for example. You'll never see that on a test. Yeah. I'm going to create another table. Depend, D-E-P-E-N-D-A or E? Doesn't look right. Depend, I think it's an E. Dependents. Is it spelled with an E or an A? Something's bugging me about this. A didn't look right. Okay, this table is called dependents. Say again. I believe so, yeah. I believe they're both words. Okay, drink of water. Now, dependent has a dependent SSN. And let's make that also a char 9, comma. He has a D. Yeah, that's probably enough. For practice, that means do not do it that way. I'll give you this file. It'll be sent out right after class. Okay. Now, tell me about a dependent. And what is the relationship then between a dependent and an employee? Assume, yeah, okay. I guess that's what I'm looking for, one to many. In other words, one employee can have many dependents. What does many mean? More than one? They can't have one? One or more? Can they have none? Okay. So how can I realize this in my database? What can I do to cause this to work? Well, I could just put the dependents into the employees table. So I could have like dependent SSN1, DSSN2, DSSN3, and all the names and stuff. And I could do that. That would be a huge waste, because what is the most number of dependents I could have? I don't think there is a theoretical upper bound. I'm sure that in the real world there is. I only have time for so many, and the IRS is going to get after me if I get too many. Don't want that to happen. I don't want them coming for getting me after me for taxes. But we don't want to do that. It wastes a lot of space. The other thing I could do, and you'll see some will try to do that, they will try to have multiple records for employee. So employee with dependent 1 in it, and then another record, same employee for dependent 2. So I have a redundancy of these records. The problem with it is if I lose the last dependent, I've lost the employee's record. So there's a lot of problems with that. We don't like redundancy. We don't like redundancy, and don't make me say that again. We don't like to have repetition. It's good for teaching, but it's not good for database. So the way we're going to do this, and this is typically when I have a one-to-many, do you see the one-to-many relationship? One employee has many, where many is defined as 0 or more. No upper bound. When I have when I can identify that one-to-many relationship, and we're going to see those over and over and over again, one-to-many, what happens is the primary key of the one side gets copied down into the many side. It should, in my opinion, keep the same name. It doesn't have to. It should keep the same name. It must keep the same type. I always use copy and paste. Okay, so there it is, the same name. Now, this is what we call a foreign key. Okay, so what happens is when I have a child and the child's name is, so the employee's name is Joe, Joe Jr. down here, Joe's SSN will come down here and be copied into Joe Jr. If he has another employee, another dependent named Sally, Sally has her own SSN. Sally has her own name. Sally has her own shoe size, her own IQ, all of that stuff, any other stuff that's there. But she will take Joe's SSN that will identify that dependent as being related to Joe. This is what we mean by a relational database. Now, there is a constraint here. FK means foreign key. FOREIGN. Usually I will get too long when I'm scrolling off the side of the page. I will usually press enter and tab at once to show that that's under this. I don't like my code to run off the side of the page. If it does, it doesn't hurt anything. References. Employee, let's see, did I make that plural? Yes. I don't know whether I should have made it plural or not. Usually I will stay with the same. If I make one of them plural, I make them all plural. If I make one of them singular, start off singular, I keep them all singular. There's no differences. Employee. Now, notice that there is no comma after the last one. You see that? If I put a comma there, I get for my reading pleasure an error message. Questions?
Should 30 have a comment?
Where?
Oh, no, okay, sorry, that was a continuation.
Here? Oh, line 30, yes. Yes, that's a continuation. It'll know where that line ends. Okay. And so when I save, I have to save. Now I can just drop back over. Notice it popped him up when I saved, and it says, hey, somebody change this thing. Do you want to load it? Yes. Notice I get it over here immediately. Okay. Now I'm going to test him by executing. Hey! It worked. In a minute, I will add, we're coming up on 6:50, so we're about to take a break. Yes, question?
So you said, see, on line 29, where you have SSN?
Yes.
Are you saying technically that name could be different?
Okay, when you see that that name is different, that doesn't conform to the rest of them in that table, does it? Because that's a D table, a dependent table. All of them in there are named D, 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 D something. Now you find one that does not conform to that. That is special. What's special about ESSN? It takes you to another table, okay? And that's why I keep the same name. Yes, it could have a different name. In my opinion, it is not good to do that unless there's no way around it. And I should be able to look at that name and tell you which table it goes to.
Could you show us an example? If you change line 29, will that change line 30?
No, no. I can name it teetotally humswoggled if I feel like typing it. And if it references employees SSN, it will continue to reference employees at ESSN. It won't change the names. If I change this line right here, I would have to change this line right here. See how he went red? But it wouldn't change the one up in the, it wouldn't change this one up here. That's in a different table. Question
On 29. So
on 29.
does your pretty much the constraint mark here, does that have to be directly beneath it on 30, or can you have additional like additional information and then just have that at the bottom, or is that so if you had, say, another field?
Good question. Question goes to what is the order of them? The order of them is pretty much irrelevant. You can order them any way you want. I usually begin with my primary key. After that, sometimes people put them in alphabetical order. I always begin with my primary key, and then I usually have my foreign keys last. There, but there's no rule that says they have to come last. There's no rule that says the primary key has to come first. I don't know whether I have always put and seen the constraints put after the fields. I don't know that that's a requirement, but I think it's best to do that because it would be hard to talk about a foreign key ESSN if I hadn't defined it yet. But I'm not sure. In SQL, you'll find that this order of things that you're used to, have you ever studied C, for example? Programming, yes. Okay, just hang on just a second. The order of things is very important there. In SQL, it gets a little more relaxed on ordering things. Question, please. Line 25. It looks like it is, yes. Yes, thank you for pointing that out. I would prefer not to use a reserved word. It's telling me it is a reserved word. Dependent, meaning that A is dependent on B. Yeah, it would be best not to use it, but it's not going to hurt anything. Correct. You are correct. It is. At least the editor is telling us it's a reserved word. You have various levels of reserved words and things in SQL. And go ahead with your next question.
Second question is,
Yes, you can. I'm not going to cover it though. Basically, you would just say references. You would just use this part right here, references employee. So you could take this, you copy this, paste it right after it, and that would be an inline. But I don't want you to do an inline constraint. The main reason we don't do inline constraints is that sometimes I will want to turn them off and turn them on for a reason. If it's not named, it's very difficult. I've got to go look up, it gets a name, it gets a very cryptic name. And I got to go look that up. So I would rather know its name from the code. I'm going to keep this code around, by the way. This code is going to become part of the documentation. Okay. If I try to run it again, I say execute and it barfs. Why? Well, actually, I thought that it would be something like this. I thought it was going to. A couple of points here. DEPEN. Now, I don't know why we got a weird, you know, it's not real consistent with its name. Okay, what does foreign key mean? I am going to give you a break here in just a second. This constraint would foreign key SSN. Tell me about the foreign key. I'm not talking about the primary key. Primary keys up in the employee table. A foreign key will always, what always, mostly always, reference a primary key. I can count the times on my hand I've had a foreign key referencing anything except a primary key. You won't see it happen in here. So as far as we are concerned, foreign keys always reference primary keys. Primary key cannot be null. There must be a primary key for each record. Tell me about the foreign key. Can the foreign key be null? Foreign key can be null. In that case, I have what's known as an orphan. Now I can put a constraint in there that says check that the foreign key name, the SSN in the dependent table is not null. Now it can't be null anymore. But just because you make it a foreign key doesn't mean it can't be null. What you're saying when you make it a foreign key is if you have one, the parent has to be in the employee table. It is okay not to be an orphan. It is not okay to have a bogus parent. May I say that again? It is okay if it's an orphan. It's okay if it's not there. It is not okay to have a bogus parent. Which table do I have to drop first? If I drop the employees table first, then all of the dependents will become bogus. Can't happen. So it's going to stop me from dropping the employees table until I drop the dependents table. We have a we have a saying in database, you have to kill the children before then you kill the parents. Which sounds a little macabre, but you have to deal with they get dropped in reverse order of the creation. Okay. There is a way to say, yeah, just ignore the errors, but we're going to go ahead and because that reinforces what we're doing here. So they have to be dropped in reverse order of the creation. You create the parent table first, then you create the child table. And then if there are grandchildren, you create them. When you drop the tables, you drop the child first, then you drop the parent. So they go in reverse order. Okay. Questions? And that takes us up to break time. And I'm sure you're dying to have a break. Let me unmute. Let's see, I got some people here. Okay. Hello, Daria. How you doing? Do you have any questions? Okay, just checking. Okay, Vanetta, are you there?
Yes, I'm here.
Do you have any questions?
Not so far, thank you.
Okay, you can send them to me. I'll send this file out. I'm gonna turn off the recording right now. The meeting will still continue, but I'm just gonna stop the recording while we take a short bathroom break. Pause recording. Okay, this is part 2. I don't think we're going to go a whole lot real late into the evening today. Oh, yeah, okay. Right back. What we're going to do in lab, I'd like for you to help me install a few computers, but you don't have to stay for lab. I'll be, well, we'll see what happens here. This is the insert. Okay, this is module 4, I believe. I think module 3 just dealt with creating tables, and I believe this is module 4. Okay, this is inserting data. You have to have created the table before you can insert data into the table. This is in all its glory. This is the insert statement. And I would like to see yours look something like this. Insert into employee, and then the list of the fields. You do not have to have all of the fields. It is not necessary that you insert all fields. You have to have all of the fields that are required. Okay, only 2 are required: the ESSN and ENAME. Well, it's only 2 I have to create a record. The rest of them can be null. If you don't have them in the if you don't have them in the field list here, then you don't have to insert them. You don't have to have a field list. If you don't have a field list, then the order that you have to specify the values defaults to the order in which you created them. Now you'll notice that what I did, I just copied these guys. Instead of typing them, I just copied this field list, and then I came down here and pasted them, took out the part I didn't need. So I just pasted them in there and took this. So mine come in order. That is not required. A little too big there. Okay. Control. Trying to roll down there we go. Okay, so mine are in the same order that they are up in the definition of the table. This is not necessary. You can put them in any order you want. You don't have to know what order they were created in. So I can insert into a table. One thing I have to know is the names of the fields that are in there. I don't have to know in what order were they created. If I don't have a field list, then I have to specify them in that order. So for example, I could take out EDOB here and take it out here. I can put them in any order up here. Just when I arrange them down here, the ones that are going in there has to match the order that they were called out in the field list. So everything that I need to know is inside of that statement. The only thing I have to know is what are the names of the fields into which I'm inserting and what type they are. Okay. It is also possible this is also legal. This guy's going to be Fred 2, and he has to have a different social security number. And let's see, now I have a comma. See if I get this right. I typically, copy and paste is my friend on these things, and I don't find that this is much help, but if you want to do it, let me go ahead and I usually line these up. And let's see, this one will have to have a different SSN, and this guy is going to be Fred 3. The 2 and the 3 don't matter. The name could be the same question. Yes, and there's about to be a semicolon here. I'm not going to guarantee that this is going to work. I might have to go back and look at my look at the syntax.
So on line 47 and 42, you don't need the semicolon after the shoe size?
Where? Here? No, that's not finished yet. This line, this is the insert statement right here. So this is the statement. Insert into this table these values. This isn't the end of the statement. The statement ends at the semicolon. Semicolon ends the statement. Let me do a quick save. Well, okay, let's find out. Now here's another trick. You can just highlight a piece of it If you highlight a piece of it and say execute, it only executes the piece that's highlighted. That's fine as long as what you've highlighted is a valid program. But if you just highlight a piece of a word, it'll try to execute that. And let's see what happens. There, yes, it worked. That's how you do that. You may do it either way.
You're highlighting just a section of code from line. I guess
Mhm.
it's dependent on
Oh, if I had that highlighted. The common mistake is to have a little bitty thing highlighted like that, and then come up here and click execute. And it says LO. I don't know what LO is.
It's checking to see if it's valid, not actually.
No, it performed this. If I said execute, it would execute that piece of code. And it did insert those guys. And if I want to see it, and we're not going to do much of this, but we don't know how to see it using SQL yet. But so I'm going to show you how to see it just for giggles. Let's see, we go to databases. This is in SW Smith. We haven't started working with AP yet. Go to my tables. I have a table called employee. I right-click the employee table, and I say edit top 200 rows. Or you can say select. And there I see all of my data, just as if it were in Access. And I can edit it. I can change it there, yes. I can add rows there, yes, but that's not what this class is about. This isn't about using the graphical user interface. If you want to use the graphical user interface, go take ITSW 1307. No, that's baby database. Database using the SQL. Database using the GUI and Access. That's a good class. I mean, there's a lot of things you can do. I'll give up my GUI when they pry it from my cold dead fingers, but there's things you just can't do with it. For example, work on a remote database. If I'm working and my database is any place but right here in this room with us, we lose that graphical user interface. Once that database moves out to New Zealand or something, I'm in a world of SQL because I just don't have the speed on that connection. I have to have a real high speed connection to use a GUI effectively. Yeah, I know, you can. Yeah, I'm aware of that. I lied, but it's better. Yeah. Yes, we do have a GUI, and then you can close it down. This class about SQL. SQL is much, much faster than a GUI. SQL is a very high-speed language, very well-optimized language. Talk a little bit about SQL. I don't have a clue what SQL is doing under the covers. Notice that we're going to find out in SQL we don't program SQL like we program a C or a Visual Basic or Java or anything like that. We specify the answer that we want to see, and SQL goes out and it gets the data for us, but I don't know how it's going to do it. I can find out how it's going to do it, but I don't know offhand. I don't really care. I just want to do it the best way I can. SQL or database in general is incredibly consumptive of memory, computer memory, and processor time. It will throw processor time at something or the memory. It doesn't care about the processor. It doesn't care about using the memory. That's my joke. How much processor and memory does a database require? All of it. Okay, it's going to just drink it to avoid doing disk accesses. But in that, it does great optimization of what it's doing. So it's very difficult for a human programmer to beat a database. Okay, so here we have insert into employee, and I guess I should also demonstrate insert into dependent, and I'll just copy those values. I hate typing. values. All SSN. Jill. And to whom does Jill belong? Fred, Fred 1, Fred 2, or Fred 3? Now, Jill does not have to have a sponsor. If Jill does not have a sponsor, we would put the word null in there to indicate that there is no a null value to be inserted there. It's okay if that record is null. This would work. It is also okay in some to just leave it blank. In other words, it put a comma, right? That will usually work. Just have an empty space there, but you have to have the comma. If you don't have the comma, it won't work. Okay. I do not like that. If you intend to put a null in something, write N-U-L-L. Say again. That little red squiggly thing is not always an indicator that there's any problem. Notice that there's a little red line under that. I don't know that there is a problem. I'm going to highlight it and we'll find out. Execute. And there's a problem there. Okay, I guess it doesn't like it. If I put it dash dash like that, two quotes together, that inserts the string that has no characters in it. Okay. I don't think it's going to let me do that because it has to reference something. So I'm going to make her belong to Fred 2. 1, 2, 3, 5. Now it should work okay. It would have worked with the word null in there. Some platforms will let you just leave it blank. In other words, have a comma and nothing there. It will interpret that as null. I guess 2016 is this, we're in 2016, is making me put in N-U-L-L. That's fine. It's better. That's really what it asks for. Now, Jill is a dependent of Fred 2. If I were to try to do another one, this is Orphan Annie. You guys know about Orphan Annie, right? Orphan Annie was a cartoon character. And so I'm saying that this is an orphan. It has no parent. And this one should be fine because there is nothing that is stopping me from allowing orphans. Orphans are okay. This one has a bogus parent. There is no parent 9999. Okay, there is no employee 9999. So when I try to execute this, the insert statement conflicted with the foreign key. Notice that I get to see the name of the foreign key when I violate it. It tells me a little bit more than that, but I'm not guaranteed to get anything except the name of that foreign key. So that's why I tend to make my names, I make the names of my constraints tell me all I can. I'll make them long because I almost never type them again. Once I've typed them once, all they are is an error message for me. So part of that error message. Good thing to have. So I see that I have violated that. In other words, I'm trying to put in a child with a bogus parent. If I want to delete a record, I have to delete the child first, then the parent. In general, though, you don't ever delete from a database. What, never? Well, hardly ever. If you think about it, you're a student at Collin College. You're in the database at Collin College. When you cease being a student in Collin College, will they delete your records? No. You're setting up a database for a medical practice. If the patient is no longer the doctor's patient, even if the patient dies, are you going to delete the records? No, never delete medical records. If you have records at a bank, you're never going to delete those records. Okay. Databases, you typically never delete records. Databases just grow. They almost never shrink. And when they do, they present us with a whole different set of problems. Databases are designed to grow and grow and grow. You almost never delete records. I'm going to talk about how you can, but let's talk about how you can delete a record. So this one is going to error out. So I can use that comment to just take that one out. That one's not there anymore. Okay. You have to be careful with this one. What would happen if I executed line 64? It would delete everything. We have a saying in database has the undo capacity of an M16. Okay? Database does not typically have undo on it. A database has a backup, but there is not, past a certain point, there is no undo. It'll keep a little bit of stuff in what we call the rollback segment. But once you say commit, make it happen, it's happened. And that's what that go is essentially. Once you say go, happen. Okay. Delete from dependent where it's DSSN, isn't it? 9876. Okay. Delete. Delete from where? Yeah, delete from the dependent table. Where, you always have a where on a delete, otherwise you're going to delete every record in that table. Right at that point, you can do an undo. You can back out of it. But you'll see that, 7,352 rows updated or deleted. Oops, wait a minute, I didn't want to do that. So you need to watch what's going on in these things. Okay. We're to 7:30. Let me, I'm going to do delete, update. I don't know why it's purple. Set what? Set E number. And which one do I want to do? 1, 2, 3, 6. This is an update. Changes it. And an or work. All that jazz. I'm gonna. I think instead of just talking on into the night, I'm gonna let you read that. It's pretty straightforward. Let's see. I can't update anything that is going to conflict with the foreign key. I can't update a primary key. I almost never ever update a primary key. Have you ever? Anybody ever going to change their social security number? Your social security number is not going to change. Try going down to the social security office and telling them that you're tired of your old social security number and you'd like a new one, please. They're going to tell you, I don't know what they'll tell you, but it won't be pretty. You almost never change a primary key. Things you change are things like, I don't know, salary or something like that, that is in flux. We'll talk more about that in a minute. Let's see. Delete, update. I think that's it. Okay, so there's the okay, I'm going to put this file out. I'll send it out as an announcement, I guess. So what I'll do is I'll attach this file to an announcement and send it to everybody instead of having to take up space on the server. Keeping it, I tend to change it every semester. So questions? Yes, ma'am. Line what? It happens to be. Well, I can, no, this one, line 41 through 44 is one statement. One insert, one statement. Usually when I am doing it, I copy and paste, 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 paste. So if you go look at my file on their createap.sql, you'll see in there I paste and paste and paste and paste and paste, and it's over 1,000 lines. Most of it's copy and paste. This one, this is the way I do them. So if I want to put in 2 of them, I will copy the whole thing and just change the bottom part of it. This is a line what now? Here? This part here? Okay. This part is I'm sorry, I did not quite follow you. Insert into employee, yes. Before you put this. Now that is optional, meaning you do not have to have it, but we will always have it. Okay, it does not have to be in that order. It can be in any order you like. I usually keep it in the same order as the table definition, but I don't have to. If I did not have this, for example, if I just took this out, it would be okay, but I would have to take it out of here also. Now, this is just another way of doing the same thing that allows me to make multiple records. I can have any number of them in there separated by a comma and then the semicolon at the end. I can't take out 50 and 51, but I don't have to repeat it every time. This is the statement. From here to here is one statement, and there's none of it that I can just take out and throw away. If I took that semicolon out and made a comma, yes. I can have 100 of those lines. I can have 1,000,000 of them. Right. But I don't really, copy and paste doesn't bother me any. I can copy and paste pretty quick. Typically what happens is usually you're making them from a file. I'm grabbing the data from some other source, from a web server, web input. It's putting it in a file. Then at the end of the day, I go through that and I parse that file with a C program, a Java, probably I would use Perl, a computer language. And I would create SQL with that language. So that program would read this file of names. It would put the commas in the right place, the quotes in the right place, everything in the right place, and it would create SQL, and then I would run that SQL.
JSON file.
What?
The web will put it in the JSON file, and the JSON file will be read by Perl and Perl.
Yeah. I mean, you could go directly from the web to your server. You could just run SQL from the web page, but I find that to be dangerous, because how do you know that someone might not insert, send you some SQL in there, and I don't want to feed that to my server because my server might just execute it. Delete from drop table employees, semicolon, commit. Oops. Sir, is your son's name drop table? Anyway, that's called SQL injection. So I prefer to grab it as a file, and then, we're getting beyond this lesson. Questions on the insert. This is basically all I want to do is just touch it here. We're gonna come back to it later. All I want to do is touch it so it makes sense for us to talk about SQL queries. How did this table come into existence? What do we mean when we talk about a foreign key and a primary key? What is a primary key? What is a primary key? Unique. Unique. What else? Only one primary key. It can be more than one field. That's a composite key. Yeah, we don't like that, but yeah. Unique. Required. That is the field by which your table is ordered, by the way. That's the way it is out there on the disk. It's really sorted by that. We say that it's not sorted in any way. Yes, it is. It's sorted by that primary key. When we say has to exist, yeah. Every record has to have a primary key. It has to be a unique primary key. Foreign key. What about a foreign key? Can be null unless you have something else that's keeping it from null. But just because it's a foreign key, it can be null. The foreign key is parent. Has to either, if it's not null, then the parent to which he refers has to exist. No. No. A parent can have multiple children. So you can have 1,000 records in there and all of them point to the same parent. No, the foreign key does not have to be unique. If you constrain the foreign key as unique, it is a special relationship. Then it is a one-to-one relationship and not a one-to-many. We're going to talk about that when we get to the relationships chapter.
You're going to cover like the auto generation.
I don't typically do, I mention auto generation, that it is possible to have a number. Those of you who have looked at Access know that Access has something called an auto number. Well, SQL Server has an auto number. I am not real fond of auto numbers, but I am going to talk about them.
But is there some, in the wrapper, is there some way to create a function to assign that?
Oh, of course, yes, yes. You have fairly powerful auto generation of the sequences. I'm going to talk about it. Yes, but I'm not going to talk about it tonight. Okay. Right now, today, I've covered creating a table, inserting data into a table are the two big things that I wanted to cover tonight so that you know how it got there. I'm going to make the assignment then as, let me take a look at my modules. Okay, create table. Okay. Assignment 3 is in, and let's see, assignment 3 is due for, assignment 3 asks you to, okay. A pet has exactly one owner. Let's see. Yeah, when you say exactly one owner, in other words, a child has exactly one parent. Okay, a dependent has exactly one sponsor. Can a dependent then have 0 sponsors? An orphan. If I say must have exactly one sponsor, then I'm denying that you can have an orphan. So you have to have a constraint in there that says check that it's not null. That's what I'm looking for. Not a big deal. I'm going to talk more about that. This is pretty easy to do. I'm just basically, we're getting started here. I'm also going to make the assignment. Let's see what this is. Well, I guess Vanetta got in because I saw her. I'm going to also assign module 4. I'm going to make that due on Friday also. It's basically module 3 is you're creating 2 tables. Module 4, you're inserting some data into those tables. You can do it all in one file, it'll be fine. Although I do want you please to turn it in twice because I have a turn in for module 4, module 3, and a turn in for module 4. I don't have a problem if they're both the same. I just need to get a turn in so that I'll have a place where your grade goes for that, okay? So if you wanna do them separately, as number 1, just create the tables. Number 2, just insert the data. That'll be fine. Or you can put them all together, just turn them in twice, even if they're both the same. Data manipulation. Let's see. We'll make this guy do. Okay, and I'm about to end the recording. For those of you who are in the other classes that meet Friday, it's perfectly okay if you turn this in Friday, perfectly okay if you turn it in Saturday. I just need something from you this weekend to give me a grade. Give me a quiz grade. Give me something this weekend that I can say, okay, you were here. I'll go ahead and do that now. I'm going to end the recording.